Hello everyone! In this video we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Square Roots. I'll leave a link in the description below so you know how to access this free worksheet. Before we really dive in, let's just quickly go over exactly what a square root is. So we've touched on exponents, and a square root is just another exponent, except it's a fractional exponent. So for example, looking just at number 1, the square root of 64 is the same thing as writing 64 to the power, or to an exponent of 1/2. So 64 raised to the 1/2 is the square root of 64. But how exactly does that help us? Well, let's go back to what we know about exponents. If we know that the square root of 64 is the same as writing 64 to the 1/2, how do we figure out what that's equal to? Think about setting up an equation. 64 to the 1/2 equals what? Let's make some variable x. So if we say 64 to the 1/2 equals x, we still don't exactly know how to evaluate this 1/2 or a square root. But think about if we were to square both sides of our equation. 64 to the 1/2 squared, 1/2 times 2, since we're raising this quantity to another power, 1/2 times 2 is simply 1. So we would get 64 equals x squared. So all we need to figure out is what number squared equals 64. What times itself equals 64. So thinking about 64, 8 times 8 equals 64. So our solution in number 1 is 8. And again, 8 times 8 equals 64, and 8 times 8 is 8 squared, so 8 squared, the square root of 8 squared, or 8 squared raised to the 1/2, that is 64 raised to the 1/2, which is the square root of 64. So writing this out, we can say that the square root of 64 is equal to the square root of 8 squared, because 8 squared is 64, and the square root of 8 squared is equal to 8. So let's practice this as we dive into number 2. In number 2, we're given that we need to solve for the square root of 36. So what squared equals 36? What number times itself or multiplied by itself equals 36? That's going to be a 6. 6 squared equals 36, so the square root of 6 squared is the same as the square root of 36. So 6 is our solution in number 2, because 6 squared equals 36, and the square root of 36 equals 6. Moving right along to number 3, the square root of 49 equals what? Well, what number squared equals 49? We know that 6 squared, based on our previous problem, was 36. If we did 7 squared, 7 times 7 does indeed equal 49. So the square root of 49 equals the square root of 7 times 7, which, remember, the square root of 7 times 7 is the square root of 7 squared. And because this square root represents an exponent of 1/2, it cancels out with that squared, so we're left with 7. 7 times 7 equals 49, so the square root of 49 equals 7. Moving on to number 4, what squared equals 0? That's 0. 0 squared equals 0, so the square root of 0 is also equal to 0. Moving right along to number 5, what number times itself equals 25? That's going to be 5. So we can rewrite this 25 as the square root of 5 times 5. Because 5 times 5 is 25, I have the same exact thing, the square root of 25. Remember, this square root is the same as an exponent of 1/2. So we can say 5 squared raised to the 1/2. So 5 squared raised to the 1/2, that 2 will cancel out with our fraction of 1/2 to leave us with 5. So because 5 squared equals 25, the square root of 25 is 5. Moving on to number 6, we have the square root of 1. What squared equals 1? Well, that's 1 squared. So the square root of 1 is 1. That's because 1 can be rewritten as 1 times 1 or 1 squared. Moving on to number 7, what squared equals 9? What number times itself equals 9? That's going to be 3. So the square root of 9 equals 3. And lastly, for this first set of directions, number 8, what is the square root of 4? That's going to be equal to 2, because 2 squared equals 4, so the square root of 4 equals 2. Moving on to our next set of directions, it's getting a little bit trickier. For this, we're going to find each square root, and we're going to round to the nearest whole number. So the previous problems 1 through 8, we got a nice integer value for all of the square roots. But that's not going to necessarily be the case for these next few problems. So looking at number 9, we have negative, or the opposite of, the square root of 200. Now, if this negative were inside the square root, we would not be able to do it with our current knowledge. That would give us an imaginary number, which we'll learn about in later videos. But because the negative is outside of the square root, whatever number I get for this square root, I put the negative right back out in front. So I know that our answer in number 9 is going to be a negative number, but we have to figure out exactly what is the square root of 200. What number times itself equals 200? There's not that whole number. So in this case, we're definitely going to need to round to the nearest whole number. But let's first find what the closest square roots are. And lots of times, in order to help us, we're going to think about different squares. So if you recall from our previous section, the largest number we worked with was the square root of 64, which was 8. So we know that the square root of 200 is definitely larger than that. So let's go up. What is 10 squared? 10 squared, we know, is equal to 100. So that's not quite equal to 200. Let's continue on. What is 11 squared? Well, 11 times 11 is 121. So we know that 11 squared equals 121. Still not close enough to that 200. How about we try 12 squared? Well, 12 squared is 144. 144 is getting closer to 200, but not quite there. Let's move on to 13 squared. 13 times itself is equal to 169. So it's close, a lot closer than 12, but not quite there. 14 squared, that's 196. So you can see that we are very, very close to that value of 200. And if we did 15 squared, which is 15 times 15, which equals 225, you can see that 200 falls between 14 squared and 15 squared. And it's only 4 more than 196, but 25 less than 15. So when we're rounding to that nearest whole number, because 14 squared is closer to 200, we're going to say that the square root of 200 rounded to the nearest whole number will be 14. And remember, there's a negative here, so this is going to be equal to a negative 14. So sometimes it's helpful to write out squares to help you with your square roots. Let's move on to number 10. In number 10, we have the square root of 144, which, if you recall, we wrote that down over here. This 144 over here. 144 is equal to 12 squared. So because 12 times 12 equals 144, the square root of 144 equals 12. Moving right along to number 11, again, we have that negative out in front, so we know ultimately that our answer is going to be negative. We just have to figure out what the square root of 80 is. So thinking about our squares, we know that 8 times 8 was 64. which is close to 80 but not quite there. So the next square up would be 9 times 9. And 9 times 9 is 81, which is very close to 80. A lot closer than 8 times 8, which was 64. That 9 times 9, which is 81, is very close to 80. So when rounding to that nearest whole number, we're going to use 9 as opposed to 8. So this, in number 11, is equal to negative 9. Moving on to number 12, again we have a negative, and it's out in front, so we know that ultimately our answer is going to be negative. But what whole number are we going to get? Well, 34 falls between 5 squared, which is 25, and 6 squared, which is 36. Which one is it closer to? It's closer to the 36. It's only 2 away from 36, whereas 34 is 9 away from 25. So because 36 is closer and 6 times 6 is 36, rounding to the nearest whole number, the square root of 34 is closest to 6. So we're going to have negative 6 as our solution. Moving on to number 13, let's go back up a little bit to where we wrote out some numbers that were helpful. We need to figure out what squares the number 127 falls in between. And looking from up above, that's between 11 squared and 12 squared. But it is closer to 11 squared than it is 12 squared. It's only 6 away from 121. So the square root of 127 is closest to 11 when we round it to the nearest whole number, and there's a negative out in front, so this is equivalent to negative 11. Moving on to number 14, we know that the square root of 1 is equal to 1, and that's because 1 times 1, or 1 squared, equals 1, so the square root of 1 is 1. For number 15, we have the opposite, or negative, square root of 36, and 36 is a perfect square, meaning that the square root is indeed an integer. 6 times 6 equals 36, so the square root of 36 equals 6. And there's a negative out in front, so this is equal to negative 6. Moving on to number 16, feel free to reference your perfect squares that we had written above, but I know that 12 squared is equal to 144, and 13 squared is equal to 169, and 148 is indeed closer to 144 than 169, and it falls in between those, but because it's closer to that 12 squared, which is 144, the solution is going to be negative 12. And as a quick side note, it is helpful to remember some of your perfect squares when dealing with square roots. Let's move on to our next set of directions. The last set of directions for this page are to find each square root. And there's not going to be any rounding, so all of these will indeed work out. The only thing that's a little different is that we're dealing with fractions. But when you have division within a square root, you can rewrite it as taking the square root of the numerator over the square root of the denominator. So diving into number 17, reiterating what I just stated, negative square root of 1/4, or the opposite of the square root of 1/4, is going to be negative. Splitting that square root up, because it's division, you can only split a square root up when there's division and multiplication. You cannot do that with addition or subtraction. Again, let me repeat this because it's very important. When you have a square root, you can split it up when you have multiplication or division, or in our case, this fraction bar, but you cannot split it up when you have addition and subtraction. So because we do indeed have division with that fraction bar, I'm going to split this up into negative square root of 1 over the square root of 4. So we have that negative out in front, so our solution is ultimately going to be negative. Now I just have to figure out what's the square root of 1? Well, that's 1 all over, what's the square root of 4? 2 times 2 equals 4, so the square root of 4 equals 2. So negative 1/2 is our solution in number 17. So for these problems, it's almost like we're doing two different square roots within the same problem because we can split it up. Moving on to number 18, there's no negative out in front, so I don't need to worry about that. But because there's division, I can split this square root up. So I'm going to have the square root of 81 all over the square root of 121. So solving for the square root of 81 first, that's going to be 9, and that's divided by solving for the square root of 121, that's going to be 11. Again, that's because 9 squared equals 81, and 11 squared equals 121. So 9/11 is our solution in number 18. In number 19, because there's division, we can totally split up this square root. We're going to take the square root of 49 all over the square root of 196. The square root of 49, well, 7 times 7, or 7 squared equals 49, so the square root of 49 is 7. And what squared equals 196? That's 14. 14 squared equals 196. So 7/14 is our solution. But it's not our final solution because this fraction can be simplified down. So always simplify when it's possible, unless told otherwise. So 7 divided by 14, think about it. 7 goes into 7 one time, and 7 goes into 14 two times. 7/14 is the same as 1/2. So the square root of 49 over 196 equals 1/2. Moving on to number 20, we're going to rewrite number 20, which is the square root of 81 over 49, as the square root of 81 over the square root of 49. Because there's division, we can split that square root up. Square root of 81, well, 9 squared equals 81, so the square root of 81 is 9. And 7 squared equals 49, so the square root of 49 equals 7. So 9/7 is our solution on this worksheet. However, if you are instructed that you should not have improper fractions, meaning that the numerator is larger than the denominator, we're going to write this as a mixed fraction because we know that 9/7 is the same as 7/7 plus 2/7. 7 plus 2 equals 9, and that's all over 7. 7 over 7 is one whole number, so this is the same as 1 and 2/7. But 9/7 is perfectly fine. If you need a review on mixed fractions, I'll leave a card over here linking you to a previous video. For now, let's continue on. For number 21, we have negative square root of 25 over 196. This is going to be equal to negative square root of 25 over the square root of 196, which is negative. Well, let's focus on our numerator first. The square root of 25 is 5 because 5 squared equals 25, and the square root of 196 is 14 because 14 squared equals 196. So negative 5/14 is our solution for number 21, since the fraction can't be simplified any further. Finally, our last problem on this worksheet. If you've been finding this video helpful, don't forget to click that thumbs up button and subscribe to my channel. For now, let's continue on. Number 22, we have that negative out in front, so we know that ultimately our answer is going to be negative. We have the negative square root of the quantity 196 over 225. So we're going to write this as negative square root of 196 over the square root of 225. Now we know what the square root of 196 is. That's 14. So we're going to have negative 14 over, well, what's our denominator? What is the square root of 225? If you recall from when we wrote out some of our perfect squares, I'll go ahead and scroll up. We had that 15 squared was equal to 225. So scrolling back down to that last problem, the square root of 225 is 15. So negative 14/15 is our final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below. But as always, don't forget to like, subscribe, and share. Happy learning!